Welcome to Proving Figures Are Similar Using Transformations. Let's talk about our first word, similarity transformation. That is when you have one or more rigid transformations, which are reflection, rotation, and translation, followed by a dilation. Let's review. Reflection is when you flip. Rotation is when you turn. And then translation is when you slide. Dilation is when you shrink or enlarge, although some textbooks might use different words. The word similar means when you have two figures that have the same shape, equal ratio of the lengths of their corresponding sides, and congruent angles. So just to show you what that is, let's say I have this triangle. I'm going to take this triangle and I'm going to copy it and I'm going to paste it. So these two triangles, since I copied and pasted, are congruent. Now I'm going to take, Now I'm going to take one of these triangles and make it bigger. Notice that the angles stayed the same. I kept everything proportional to itself as I enlarged it. So now I can say that this triangle is similar to that one. And that's the symbol for similar. Sorry, too many words with that letter S. All right, so now we have to find out what is the sequence of similarity transformations that make the red shape become the blue shape. I can already tell that the red needs to become smaller and needs to translate down. That's going to be my guess. So something like that is going to happen. All right, so first, before I even start, I can actually count from A to B, 1, 2, 3, 4, that this is 4 units long. And this is also 4 units long from C to D. I'm going to compare that to the blue. So I know that EF seems is corresponding to AB, and that is 2. And then from GH, that's also 2. How come I'm not using distance formula? Because those lines were perfectly horizontal, so I can just count the boxes because that's counting the units. All right, so it does look like it's dilation, and everything does look good so far. So, do I have the scale factor? The scale factor I do have. The scale factor is going from the red to the blue. Okay, so going from AB, which is 4, and transforming it to EF, which is 2, you can tell that your scale factor is going to be 1/2. Don't forget that multiplying by 1/2 is the same thing. That's what this double arrow means, same thing, as dividing by 2. But for a scale factor, we always want to multiply. All right, so I found the scale factor. We're half done. The only thing left is to figure out how we have to bring the red down here to the location of the blue while shrinking it at the same time. So this is what I'm going to do. I'm going to write down all my coordinates of the red one. So stay with me. I am going to color coordinate. Right here, this point A is 1, 6. B is going to be 5, 6. Right now we're at C, -2, 2. And D, hopefully I fit it, is 2, 2. Just enough. Then from there, I'm going to do your scale factor. So these are going to be all multiplied with 1/2. Okay, so when you do that, it will become, I'm actually going to still do this in green, 1/2, comma 3, 5/2, comma 3, negative 1, 1, and 1, 1. Good. Then from here, you are going to have to take all of these, which are now becomes your A prime, B prime, C prime, and D prime, and plot it here so you can see what's happening. I'm going to actually erase this so I can plot it for you. So we're at the green part. All we did was dilate. 1/2 3 is right here. Then we got 5/2, which is 2.5, comma 3. Then we have negative 1, 1. So this is C. And we have 1, 1, which is D prime. D prime. So as you can see, this is the green parallelogram that I'm going to have to bring over here eventually. Let me put it back where it was. How am I going to do that? You can just compare my green to the blue, because the blue I can extract some information from the blue, no problem. I can just get all of the coordinates of the blue. So here is what is E. So E is 5/2, comma 0. Then we have F. F is 9/2, comma 0. The one that corresponds to C is G, and G is 1, negative 2. And then H is 3, negative 2. Right? I'm sorry if you can't see that on that side. I'm going to actually put it in white so you can see a little better. All right, so now you just have to find a relationship between this green and how you can transform the greens to become the blues. As you can see, these are fractions. These are also fractions. I would say that these two right here are the ones to work with because you can kind of see the relationship better because they are integers instead of rational numbers. Rational numbers are fractions. So how do you get from negative 1 to 1? You would have to take your x, which is negative 1, and subtract or add. The answer is add 2. So that is my guess right now. Not sure if that's right. Let me just do an example. If I take my whole shape and go to the right 2, so 1, 2. Does it look like it's going to eventually line up with the blue? Yes, it looks like going to the right 2 helps. Then we're going to have to find the relationship with y. So if you have a positive 1, how did it become a negative 2? And if that's too hard to figure out, what I'm saying is, how can I get this point, for example, to match up with this point? How many units down do I have to go? The answer is, if you want to go from 1, it looks like I'm going to have to subtract because I became a negative number. I am subtracting 3. So I think that my answer is x plus 2, y minus 3. Okay, so I already did x plus 2. That means going to the right. Let's go down 3. 1, 2, 3. That means we have our correct answer. Our answer was to move it x plus 2, y minus 3 after a scale factor of 1/2. If that was confusing, we have another example. And for this example, we are doing it differently. We are going from the blue to the red. So that means we are enlarging. That means our dilation is probably more than 1. how many of these blue, if you're looking at the area, can you fit into the red area? Let's say I think the scale factor might be easier than we think. Maybe it's a whole number. What I'm going to do for you is I'm going to write down J, K, and L. Here's J. J is at 0, 1. K is at 1, 2. And then L is at 3, 1. Okay. Now I need those to become something bigger. I think that my scale factor might be 3. So let's see if it's 3. Remember, this is all guess and check. I'm going to try a scale factor of 3 because I know it's going to make things bigger. And I'm thinking that if I were to color this in, I think that this, what I colored in, the area, is going to be more than 2 of them. Sorry about that. So what I'm saying is that I think that this little blue shape, I think minimum 3 can fit maybe. Maybe it's 4. We'll find out. So that's what I'm going to do first. I'm going to multiply everything by 3 just to see what's happening. So that means J prime is 0, 3. K prime, remember we're multiplying everything by 3. So let me put the word multiplying just so you remember. Is going to be 3, 6. And then this will be 9, 3. So L prime is 9, 3. So let me actually graph that for you onto the coordinate plane. So 0, 3, 3, 6, and then 9, 3, which I can't really do because I have 6, 7, 8, 9. 3 would be right here. Sorry about that. So there is my shape, roughly. All right, now how would I take my shape and transform it to the shape they have there in red? You need to think to yourself, it's definitely a rotation. But what kind of rotation is it? Is it clockwise or counterclockwise? And the answer is most likely counterclockwise. Oop, it's going to take everything with us, but this is counterclockwise. Okay. All right, here is counterclockwise. As you can see, you can't see it, but it looks like a reflection of itself. So I am going to add that I think there is a reflection needed in here as well. So maybe I shouldn't multiply everything by 3 first. Maybe I should reflect it first. So let us do that. I am going to erase this here. And let's try, let's erase the green and let's try reflecting it first. So if we reflect it first, I will do that in orange. So reflection, and I know it was reflection because I turned it for you and it was looking like this. So maybe it's a reflection, then we could work with it. So we're going to reflect it across the x-axis first, just to see what's going on in that term. Because if it's not the x-axis, it's the y-axis. So here is the reflection on the x-axis. Pretty easy to do because all you're doing is making it equidistant from the x-axis, so you can kind of see what it's supposed to look like if you're looking into a lake. So it'd be 0, -1. Then it would be for k prime 1, -2. And then for L, it would be 3, -1. Pretty easy. You can see that the x stayed by its the same, but the y was transformed by putting the opposite sign. Now let's take this and make it bigger by a scale factor of 3. I think we're ready for that. So we are using our new terms to make a scale factor of 3. So then that means that it becomes 0, negative 3. Then it becomes 3, negative 6. And 9, negative 3. Okay, I do know that that is the correct shape because I drew it before. And then from here, that means that we have this shape that I drew. We have it bigger. That is the only thing we did. Not like this, I'm exaggerating a little bit, but that's because I don't have enough space to graph it. And I want to rotate it this way. After rotating it this way, I'm going to line it up and everything should be good. So I'm still rotating in the direction I need to. That is called counterclockwise. So we're almost done. So let's do counterclockwise. And we're going to do that 90 degrees. Okay. What is the counterclockwise rotation formula? It's when you take the y, put it in the first position and make it the opposite sign, and you change the x. Okay? So that's what we're going to do to the green. I'm going to put the y in front, make opposite sign, and leave the x. So that means it's going to become, we're finally ready, 3, 0. If you're looking at this one over here and compare it to what I have here and look at the formula, let me know if you have any questions. So now I'm going to do 3, negative 6 and do it with negative y comma x. So that's going to become positive 6, 3, because I brought the 6 to the front, change the sign. Then from here, we have to do 9, negative 3. Do this formula, and you will get 3, comma 9. All right. And how did I get that? The y goes in front, changes sign, and the x gets pushed to the back. And those are your answers for doing a counterclockwise rotation on this shape. If there's any questions, please don't hesitate to ask me on Google Classroom or through Remind. This slide was from SlidesGo. Thank you for watching.